There are lots of things that we can do with radicals or square roots. We're only going to look at a couple of them. The first thing that we want to talk about is multiplying and dividing radicals. In order to do this, you do need to remember how to multiply monomials and remember your exponential rules. And you also need to be able to factor numbers. We will be doing a very specific factorization when we talk about simplifying. So in this section, we're going to work with two different rules. These rules are going to be very similar to our exponential rules. The first one we have is the product rule. The product rule says if you have the square root of a times the square root of b, then we can combine this into a single square root, which is the square root of a times b. Now in this section, we're going to see that sometimes we're going to combine, other times we're going to separate. The other rule we have is the quotient rule. And this quotient rule says if we have the square root of a over b, we can separate this into the square root of a over the square root of b. Same thing, we can either go from left to right or right to left. We can combine or we can separate. With these first set of examples, we're going to talk about our product rule. We're going to talk about combining our square roots together. So what we want to do is we are going to multiply or divide the insides so that there is only one root. And from there we want to simplify the square root if possible. So let's go ahead and look at some examples. Example A, we have the square root of 2 times the square root of 5. I can combine this into a single square root by multiplying my insides. 2 times 5 is 10, and so we get the square root of 10. We're done. If we come over to example B, this may look more complicated, but it's going to be basically the same thing. I want to multiply my insides. 7 times 11 is 77. I have an x and I have a y. And so our final answer is the square root of 77xy. Let's come down to example C. We have the square root of 7 times the square root of 7. If I multiply my insides, I get the square root of 49. Now 49 is a perfect square, so I can simplify this. The square root of 49 is 7. And finally, example D. We have the square root of 2/5 times the square root of 3/7. So this one, same thing, I'm going to multiply my insides together. And recall that when we multiply fractions, what we're going to do is we're just going to multiply straight across. 2 times 3 is 6. 5 times 7 is 35. And so our answer is the square root of 6 over 35. So there are some basic examples of combining square roots. So the next thing we're going to look at is simplifying square roots that are not perfect squares. This is where we're going to talk about separating the square root. So our procedure is we want to split the square root into two groups. In our first number, we're going to have perfect squares. The numbers that we want to work with are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and of course this list goes on forever. For our variables, we want to select the largest even exponent less than or equal to the exponent in the problem. Recall that if it is an even exponent, it is a perfect square. Our second group is going to be our leftovers. And one thing to note is that it should contain no squares. The most variables that can be in the singletons group is variables with no exponents or an exponent of 1. Our next step is we're going to take the square root of the first group, and we keep the second group inside the square root and bring down to the final answer. So let's go ahead and look at some examples of this. So for our first example, let's look at square root of 75. I want to factor this, and I want to pick special factorizations so that one of the numbers is a square. So if you look back at your list of square numbers, do you see one that divides into 75? The answer is yes. We should be able to separate this into 25 times 3. Again, these are inside square roots. Now we want to take the square root of 25 and we get 5. My 3 stays inside. So our final answer is going to be 5 square root of 3. Now another way, if you struggle to recognize squares, if you don't know your squares off the top of your head very easily, you can also use prime factorization. So if I factor 75, 75 I know is divisible by 5. If we divide 75 by 5, we get 15. And 15 is equal to 5 times 3. So if we go with the prime factorization method, we are looking for perfect squares, which means I am looking for pairs of numbers. I have one pair of 5s. That is going to be what goes outside. My 5 goes outside. And we have 3 left over. That is the number that stays inside the square root. Either method, you should still get the same answer. All right, let's look at F. So this one, again, I want squares that divide into 80. Now, some of you may be sitting there and saying 4, and 4 is okay, but it's actually not the largest square. And we are aiming for the largest square that divides into 80. The largest square that divides into 80 is 16. 80 is equal to 16 times 5. I'm going to take the square root of both of these. Square root of 16 is 4. And we leave our 5 inside the square root. So let's go ahead and look at this one in terms of prime factorization. So 80, what multiplies to 80? I'm going to go with 8 and 10. Things that multiply to 8, I have 4 and 2. 10 is 2 and 5. And 4 is 2 and 2. This is now completely factored. So what are we looking for now? We are looking for pairs. So I have one pair of 2's, and I have a second pair of 2's. So from each one of those groups, I can pull out 1. I get 2 times 2 times the square root of 5. Since 5 has nothing to pair up with, it is going to stay inside. From here, I want to multiply my outsides numbers. 2 times 2 is 4, and 5 stays in the square root. So notice that either way, we still get the same answer. All right, let's look at example G. We have the number 55. If you try to factor this, unfortunately, I'm going to do this using factor trees. The only thing that multiplies to 55 is 5 and 11. Neither one of these is a perfect square. And so what we say for something like this is that this cannot be simplified. So not every square root simplifies, but if it does, we should go ahead and simplify it. Okay, let's look at one more example and let's bring in some variables. So for this one, I want to start by factoring my number part. The largest square that goes into 72 is 36. 72 is equal to 36 times 2. Now our x to the 14th, 14 is an even number, and so I'm going to put it in my first group. I'm going to put it in with my squares. Now when we take our square root, we get the square root of 36 is 6. And now what do you think the square root of x to the 14th is? Square root of x to the 14th is x to the 7th. X to the 7th squared is 14. So the square root of x to the 14th is x to the 7th. So a quick trick that you can do here is, since we are dealing with square roots, our rule for roots is we are going to divide the exponents by 2. 14 divided by 2 is 7. We still have our 2 inside our square root, so I'm going to go ahead and bring that down. Alright, so let's look at this using factoring. If I factor this, 72, give me two numbers that multiply to 72. I'm going to go with 8 and 9. 8 is equal to 2 times 4. 9 is equal to 3 times 3. And 4 is equal to 2 times 2. If we look for pairs, I have a pair of 2's. I have a pair of 3's. I have 1 2 left over that will stay inside. So far, this is what we have. We have 2 times 3. We leave our 2, our leftover 2 inside. We can also do this with x to the 14th. X to the 14th, this is going to be 14 x's multiplied together. (10, 11, 12, 13, 14. All right, if we pair them up, let's see what we get. We get 1, 2, 3, 4, 5, 6, 7. We have 7 pairs of x's, and so that 7 will be our new exponent on the outside. Now if I simplify this, 2 times 3 is 6, x to the 7th, square root of 2.